Mic check. Check, 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 check. Mic check. Check, 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 check. Okay. That was a saga, but after a bunch of background work, which mostly involves a lot of rebooting, I have the eGPU working here. But the caveat that it is working, but not under Linux, under Windows. It is possible with the knowledge that I've gained that I can make this work under Linux now. And that will have to be another experiment. But I'm actually not super inclined to do that because the Wi-Fi works perfectly in Boot Camp Windows. So the overall setup is much more stable. It doesn't involve me trying to figure out how to deal with that wonky Wi-Fi. And so if I end up going back and trying it on the Linux card, it may just be to satisfy that I can get rid of this RME init failed message, but I probably will not use it for the show. Because the other advantage of doing it under Windows is then between the mobile streaming setup, my desktop computer, and the OBS Hub VM can have a consistent set of paths to the Google Drive where all of the streaming overlays and assets are. And that means that the scenes or the scene collections should be portable between environments. Meaning I can work on a scene collection on one computer and then save it into the drive and then just load it on another computer, and it'll be the same because I'll have the same drive mapped to H on all of the computers. All of the assets will be available on that H drive, and then everything should just sync and just work. And that's very attractive. So how did I get this? What was wrong and how did I get this working? So when you install the stock configuration in Windows, meaning I install Boot Camp and then I plug it in the device manager, the GPU does not become enabled. It shows warning error, and inside of the little message box inside of the device manager, that when you open it up, it shows this dreaded eGPU error 12 fix, which seems to happen to a lot of people, and in particular to Mac owners. Error 12 in Windows, it'll say, and I might show it to you later, could not allocate resources to map this PCI device. So essentially, it does have something to do with the address range, and it just cannot memory map in the cannot memory map in the device, the PCI device over Thunderbolt. And the solution to this, which people have found, is it is possible to rewrite the so-called DSDT, right, the device-specific something table. And this is, I don't fully understand why this is part of the ACPI spec, which is generally used for like power events. So the famous thing, of course, with ACPI events is this is the thing you got to do in order to get sleep, hibernate, The ACPI was all the rage, all the issue on Linux going way back, because for laptops, right, the ACPI is really important. If you don't respond properly to the ACPI events, then like you won't know whether or not you woke up from hibernation or from suspend. You won't know what the right thing to do is. But apparently the DSDT, and of course, in order to read this information, I think what's happening is the operating system needs to know that there are certain addresses that it needs to read, right? And the operating system needs to know where to get this information from. But apparently this table also defines the way that PCIe devices are mapped into address space. And I guess the 32-bit space isn't big enough, and through software alone, through the DSDT definition, you can redefine this space to be 36 bits instead of 32 bits, and therefore make space for the device to get connected, right? And for Windows to be able to access the device. The actual situation is a little bit more complicated. So we see here, I guide MacBook Pro solving eGPU error 12 in Windows. There's actually many possible causes of this, because it's not just the DSDT space, right? The mapping address space that's the problem with Windows 12. There's a second interaction. So you have a couple of then solutions, a whole list of things for you to try. And people are like, oh yeah, it takes me different MacBooks, take a different set of combination of things to make it work. And apparently, yes, we need a different combination of things to work. The first and the easiest, which for me didn't do anything, is this apply hack flag set 0x00 registry. Apparently there's a registry setting, and if you set create a registry setting called hack flags into PMP PCI hack flags, then magically Windows will do something that makes this work. That did not have any effect. Second one, which gives you an idea of one possible solution to the problem, is hot plug your eGPU after boot up to delay firmware initialization of the GPU. So when the GPU is plugged in theory, the OS may be able to allocate it some addresses or something at boot time that it's not able to when it's hot plugged, being that it's a laptop. And so there are many cases, especially in the Linux side, where you say, well, you can only make the GPU work if it's plugged in when you boot up. If the eGPU is not plugged into your laptop while you boot, then you hot plug doesn't work. Right? It's a very common thing. It's like, oh, in your eGPU setup, does hot plug work or not, right? Like on my desktop computer, no problem. My desktop computer has huge I/O space and hot plug works fine, but for laptops, apparently this is a thing. Now, the problem with having the GPU installed in hot plug is then the OS tries to do something, negotiate with the GPU as part of the boot sequence, and it disables the internal iGPU because, hey, you have an external video card, so you don't need the internal one, right? It's very common, right? Because this is a Intel chipset, right? It's got the Iris Pro graphics, and so it's very common in motherboard with integrated graphics to say, oh, I've got an external card, so I can disable the internal card by default, and then you can. Like on my desktop, there's a BIOS setting, right, which allows you to override that behavior and say, no, right, even though the external is plugged in, I still want the internal card, graphics activated, right? Otherwise, it'll be deactivated and won't even present as a PCI device. But of course, you can't easily control that on a Mac. Because you can't get access to the BIOS settings, right? Those are all hidden. So this is like, okay, you want to hot plug and delay the firmware initialization of the GPU But if you do this too early, then the iGPU will get disabled and then you can't boot. It'll crash, right? So then there's, another option, right? Set OS EFI, which basically sets it up so that it sends some EFI, runs some EFI script to send some signals into the PCI bus. And that will force the iGPU to remain active and allow boot to continue while having the GPU connected during startup so that the OS can read the addresses and allocate the addresses early in the boot sequence instead of having to do hot plug. In theory, that should in many cases resolve this issue of not being able to allocate address space, right? The underlying error 12 issue for the PCI card. And then some specific thing about using dGPU hosting, and then a whole bunch of weird ass stuff around trying to clear out PCI address space, right? 5, 6, and even 7 is kind of like this, which is like disable other devices to clear out some PCI address space. Then disable and re-enable your eGPU first after plugging it in, and then try to see what else you can activate before you run out of address space. And then DSDT override, which in theory should be the mother of all fixes because it increases the available address space. But this is a pain in the ass, as I'll show you in a moment, right? And so this is like, no, this is a last resort, right? So the guy who wrote the documentation for this, like, doing this DSDT override is a last resort. Make sure you've tried everything else. And then this VGA enable bit using Refine, which is very similar to the set OS EFI thing. So basically, following the instructions, I went through and I tried all of these, leaving the DSDT to the last, like they recommended. And I had them all installed and it didn't work. Then I did a DSDT override and I didn't do it right. And that bricked the install. And in Boot Camp, there's no good way in Boot Camp and Refined, there's like no good way to force Windows to go into safe mode early in the boot sequence unless you've prepared for it. I didn't prepare for it, hosed, had to reinstall. And what ended up working for me is a combination. Then I did the DSDT override again, a second time. And then added, and that didn't work. And then I used the Apple Set OS EFI, and now it works when it's connected at boot. Hot plug does not work. And so DSDT is not didn't work. At least it doesn't work for me that this expanded address space doesn't work for hot plug, but it does use the expanded address space in order to successfully map the device when it's connected at boot, and then Apple Set OS EFI keeps the iGPU on. So the big thing here through these instructions is when I messed it up, bricked my Windows install, had to restart it, what went wrong? I want to show you how I did it eventually the correct way. So I went through the default mechanism, right, which is you download some of these Windows tools, the Windows binary tools and the driver kit. The binaries tool gives you a way to dump the current DSDT that's loaded. There's a default one in the BIOS. It allows you to dump the DSDT, and then you can edit it in a human readable format. Then you can recompile the DSDT and then set it back into the OS. And when you use a custom DSDT, Windows treats that as a driver. So it's relatively easy. There's a command that will do it, but it won't take an effect unless you're in test mode. And so I'm in test mode because the way to make this work if it's not in test mode is this kind of memory MBR over this in-memory substitution. But this Clover bootloader in-memory substitution here is considered dangerous because this puts the DSDT, I think, into the firmware of the Mac itself. So if you screw that up, then your Mac, the hardware, is done. right? Because if you have a bad DSDT at the firmware level, there's nothing you can do. You're hosed. Because I messed up the firmware the first time, I'm like, I'm not doing that. Plus, there's a lot of mention here of using Clover. Clover is the bootloader that's used in Hackintoshes to load Mac OS into regular EFI compliant boards.
53 has invaded the chat.
And Clover is not designed to be installed onto this wacky Mac, onto Mac hardware, which has a lot of weird stuff in it. And so, in general, putting Clover onto a real Mac, onto real Mac hardware is a dangerous thing. So I did not do this. I'm in test signing mode, right? So I went through this first and did the DSDT modification. And essentially, when I run ACPI dump -b-z under Windows, an error occurs. A DAT file is generated, but something is not right with the generated DAT file. And if you power through with the modification procedure, it'll break your computer. Or it'll break that install. What I did after scrolling down, right, you see that there's a way to do this on a Mac using the tool Mac iASL. And we head over to the Mac, right? I've got Mac iASL installed. And this process this Mac iASL is an IDE. So first, I don't need to download multiple different tool chains and do different stuff, right? When I load it up, it pulls up, it can read the system DSDT automatically. And actually, there are two file formats related to this DSDT format: an AML, which is the ACPI machine language definition, and then ASL. And ASL is the symbolic or scripting format. And so essentially, it pulls the ACPI, the DSDT, and then can kind of disassemble it, right? I see it says here, AML disassembler. It disassembles it into into the assembly language, I guess. Or in some cases, it looks a little bit like VHDL. I guess it's conceptually maybe similar to like VHDL. And so you have to go to this right location, right? You go into this IDE generates DSDT, and then you have to go into the into SB. PCI 0, and then HDEF, and the second one here is DSM, right? So you're down here in DSM, and then you need to make a modification, right? The keyword modification. So we're going to search here for resource producer. And we're going to look for the last D word for resource producer. Now, these are addresses, right? So there's nothing theoretic about this. These are all just magic numbers that describe the memory mapping of the hardware, I guess. And then right here before this method CRS0, you add in another, I guess, memory space definition. Right. I guess you add another memory space definition. And right, so after the D word, you add in this Q word memory bit, which defines another memory space range, which I guess is going to define another large memory range in PCIe. And so then when we come back here, I can come back and do a save as, and in the Windows process, there's this whole thing where like you have to get you dump the DAT file, and then you convert the DAT file, disassemble the DAT file into a ASL file, and then you take the ASL file, you edit it in Notepad++, then you save back the modified ASL file, and you compile that ASL file into a modified AML file. Here in the IDE, all those disassembly and compilation steps are all done for you in the UI. The UI will automatically, when you launch it, will dump your system's DSDT and decompile it all in one stroke. And then when you save, you will save it as a AML file. And when you say save, it's really compiling. It's compiling the disassembled ASL into AML when you save it. But this essentially makes this a much simpler load save operation. Didn't get any weird errors. I saved the modified DSDT, put it onto a memory stick, and then brought that over into Windows. So let's head over, let's restart. And then let's go into Windows. So in Windows, you continue on with the instructions as is, meaning you go and I have to copy the modified AML file that I got out of the Mac iASL tool and do this ASL load table and then turn BCD set test signing on. So now I'm in Windows, at least I'm always in test mode. And so you can see in Windows now, hey, I'm in Windows on the Mac, right? I'm in test mode. Let me change my screen resolution here. Let me just bump up the scaling. You can see this a little better. So let's head into the device manager. So in the device manager now, and so let's say I've done the DSDT thing, right? So in the device manager, when we go over into resources by type, there's a large memory space here from C20000 to E0FFFF, which matches the memory space, right, that we created here in this keyword memory. So here's a C20000 to E0FFF, right? So now this memory mapped, extra memory mapped region for I/O, and don't ask me how this Windows this gets compiled and Windows interprets this as more I/O for memory mapped devices. And there's a large memory segment here, and then we can see that actually, right, because it's actually, this is 16 16 digits long, right? So it's the first digit is 00000C over 2, right? So 1, 2, 3, 4. So actually, 1, 2, 3, 4, 5, 7, 8, right? So even these serial UART devices now and this HD audio controller, these devices have been mapped into the large memory space that were defined in this PCI root complex. So we've saved some address space here. And then let's see what happens. Go back to devices by type. Let me plug in or on the eGPU. I'll plug this in here. See what happens. All right. And so it shows up, but NVIDIA GeForce RTX 3060 exclamation point, right? And this error message is this famous code 12. The device cannot find enough free resources that it can use. If you want to use this device, you will need to disable one of the other devices on the system, right? So this is not enough to create space. Now I can't easily uninstall this, so I can't prove that then what I'm about to do, did not work on its own. I can only tell you because it was much easier that what I'm about to do did not work on its own. The second thing that I needed is I need this guy connected to the laptop earlier in the boot sequence so that Windows can take it into account earlier in the boot process. And in order to do that, I need to make sure that the iGPU stays on and stays primary even when the eGPU is plugged in. I don't want the Windows boot process to think that the eGPU is primary and then take over, right? Because if I do that, let me show you what happens if I now have the eGPU plugged in, and I'm going to restart. And when I restart normally with the eGPU plugged in into Windows, the fans are spinning, Windows icon shows, but no, the dots don't appear down here. It just hangs here forever. It actually does get somewhat later in the boot sequence because at some point the touch bar will light up, meaning that the touch bar gets initialized, maybe. But there's nothing getting sent out. The card's completely idle, right? The fans aren't moving. And if you plug in HDMI, there's no signal going out. So this guy is dead, right? So this is the problem with just having the eGPU plugged in during boot. Is the normal behavior is disable the iGPU and then doesn't work, dies out. What there is this EFI image, and when you run it, this Apple set OS EFI image. And this is usually for people who like, in particular, they want to do these prime render offload kinds of things. And this is at this guy's GitHub project. Right, head over to OXBB, and here's the source code, and then there's some packages he has here. And this is essentially, it's an EFI boot image that that when you run it will send some PCI commands that should keep the iGPU alive. In theory, if you're using like the built-in bootloader or whatever, you need a little bit of EFI scripting so that it will run this image first, and this .efi is essentially like a program. It can continue into boot or it can return. And in this case, this will return to the bootloader. And so you need a little bit of EFI scripting to execute this, and then afterwards load your load the EFI boot image for your
has invaded the chat
for your hardware. But because I'm using Refined, I'm doing that. I'm not scripting it. I mean, I could, but EFI scripting is its own thing. So I haven't delved into it. What I did is I just put the Apple Set OS EFI onto the ESP EFI partition, so it looks like a custom EFI boot image. And then when I run it, it just does it. And this is kind of useful because apparently it doesn't always work. You sometimes need to do it multiple times. So I can just hit it a few times. And then I will boot into Windows. And now you see, hey, I got spinning here. And my eGPU is plugged in. And this is something I added afterwards, right? The menu to boot into safe mode, which I have to add in like using msconfig and bcd edit. But I actually think that this is a little bit too late. By the time I died during that initial spinning, when I had the bad DSDT. So I'm not 100% sure that would save me from bad DSDT. And now you'll see down here, hey, look at that. I've got NVIDIA settings. NVIDIA detected that I have an RTX 3060 connected. And if I go to the device manager, go to my display adapters, hey, I've got the RTX 3060, and it's working totally fine. And one thing I want to check that I didn't look at previously was I want to see where two, three, four, 5, 6, 7, 8. So this is not in that extended address space. Oh wait, yes it is. Or rather there's two of them. So there's one piece of it, and I don't know why it's two. I'm not a hardware guy. So there's a piece of it down here. And then there's another piece of it up here. And you notice there's a lot more stuff up here. So we had, from when I rebooted, everything up to the host controller was here, plus the RTX 3060, and then the root PCI Express port, number 9. Number 9 is the guy on the right, is on the right side. The right side ports are number 9. And then this. Yeah, so the 3060 has, I guess, multiple ranges, and it needs to be in this higher range. Just using Apple EFI, Set OS EFI was not enough. That was like the first thing I tried because it's so easy, right? It's just basically a copy on this, put it onto a stick from my desktop, boot into recovery mode, copy that onto the EFI partition, and then just spam it and refine. But no, that didn't work. Yeah. Now, another interesting thing, although I have it set up here, I'm going to do a little benchmark right now, is that the left and the right sides are not the same. The right side, if I come in here and go into the NVIDIA control panel and take a look at system information. What we'll see down here is that the bus is on a PCI Express X2 Gen 3, right? So there's only 2 lanes. And at first I thought, uh-oh, did I get a bum? Did I get a crappy, you don't need that, no signal. Did I get a crappy NVMe to PCI adapter that only has X2? No, it's not. That's actually not the problem. If I plug this into the left side, I get X4. And the reason for that turns out when I picked up HW info, and this was something that was also discussed in the forums. Probably the eGPU forums are really like just a lot of old stuff that's like outdated, stuff that is potentially like wrong and damaging. So I had to watch out. Is that if I take a look at the topology of this bus under bus, right? Here I've got PCI Express root port 9. And you'll notice that under root port 9, this first bus up here is only X2. And then I have one of the Alpine Ridge Thunderbolt switches in here. And the Alpine Ridge Thunderbolt switch is X4 capable, as are the, where is it? Where's the one that contains the card? Here we go. As is another bridge, right? And then there's the 4C. And then I think the 2C is, maybe the NVMe adapter. And you see that I've got then the RTX 3060, and there's the audio controller for the HDMI output are here, but all of these are X4 capable, but they're stuffed under the X2 bus here early on. Whereas and there's a 1X bus, but that's for the network card, which is fine. All right. And then there's port number right. So there's Realtek USB GBE family controller. That is that's the gigabit Ethernet port on this guy, which power's coming in, there's Ethernet, right, and then it's coming in through the left side. And this guy is under the root port, it's X4 all the way. And so if I plug the GPU into the left side, and some people have on some MacBooks have reported wonkiness where like the port in the back versus the port in the front are different. I did not experience that, and that doesn't make any sense to me, because these are the left. There's two Thunderbolt switches in here, right? There's two Alpine Ridges, so makes sense that the two Alpine Ridges might be connected to the motherboard differently, but the Alpine Ridge is it's a switch, and so the ports should be the same. And I found that they were the same. So I've tried, and you have to reboot every time you do this, right? So I rebooted 4 times and tested the card on all 4 slots, and all 4 slots work, and it's X2 on the right side, and we see X4 on the left side. And then in Windows, very conveniently for hybrid graphics, it's pretty simple here. Under graphics settings, it has a list of the installed applications, and then you can determine where the rendering for that application should go. Should it go on the high performance, right, onto the 3060, or onto the built-in device, or let Windows decide, which is like mysterious. And it can swap. I once jiggled something and got the card disconnected during power saving, and it flipped over. It didn't crash the computer, which is good, I guess. And so now I've got OBS Studio. Okay, so this this scene doesn't load super well. Let me hold on. Let me change the scaling. Back to 100. So here's the OBS. I'm gonna have to probably just talk you through it because you're not going to be able to really see what's going on in the screen. And let me open up the task manager. Let's double check that. Yeah, so the task manager is in good shape in that I've got I cannot make the task manager bigger while making OBS leaving OBS the same. So I'm just gonna have to leave this as is. Task manager is here, and we can see that I've got it recognized both the GPU, internal GPU, and the external GPU. So let's see what I can do with this with the X2 bus. And then maybe if I have time before I get hungry, we'll see what I can do if it's any different in the X4 bus. So let me first, I've got a capture card and I've got HDMI connection on this end, and then I'm gonna plug this into the hub back here. Okay. Setting up the cam link. Cam link does not need any special drivers. And then I'm going to plug this into, well, you can't quite, whoops. Right, cam link is ready to go. You can't quite see that I've got a camera here. I get the camera. Yes, kind of. Right. Okay, so I mean, you can see what the camera is pointing at, nothing significant. So I need, oops. The mini HDMI to HDMI adapter. Turn the camera. I'm going to take the lens cap off. Plug in HDMI. The scene's not terrible. I can see a little something in there. Now let's add the cam link as a source. Video capture device. Create new cam link. Okay. And not the FaceTime camera. I want it to be the cam link. Key. Disable buffering. The aperture a bit. Wait, look at that bokeh. Okay. Okay, so I've got the cam link going out, and so far, very little, and there's more GPU usage now. 24%. CPU usage is still low. That's good. Now let's set the stream settings. So I'm going to set this to bandwidth test mode, which I think should still exercise the whole chain. Right? And NVENC gets detected. That's good. So OBS sees NVENC. Let's set the video bitrate to 6,000. Audio bitrate to 320. Coder preset. Let's set it to max quality for now. Not going to record for now. I'll deal with that later. 48 kilohertz audio and no audio sources. Video. Oh, I want the output resolution to be 1080p. Advanced. Oh, we did everything. All right. NVIDIA, don't rescale, rate control, CBR, 6,000, preset, max quality. What is the GPU number? I don't know. We'll see if this works. Video, hotkeys. Okay. Process priority. Stream is bandwidth test mode. Okay. Yep. Let's go for bandwidth test mode. And dude, where's my task manager? Performance. That's good. CPU usage is low. Do some compositing now. Do some compositing. So let me add in a image. We'll call this, call it header. So there we go. Over, let's pick up some artwork. Why is this so big? I changed my scaling. I'll pull up episode 3 for now because I don't have the episode 4. Whoops, No. Now I've got some alpha compositing. Still pretty stable. Let me pick up another image. I'm going to call this the timetable. So even over X2, alpha compositing, no challenge. Yeah, clearly it's doing work, right? The encoder's going, some copies, some 3D, not a lot else going on. And then let me try the, all right, let me log. Oops. Let me get log into Twitch. Probably want to stay logged into Twitch. Authentication. Okay. Yeah. And I mean, I can do stuff. I can do stuff, and I don't lag, right? I didn't. Little bit of rendering lag, right? Just a minuscule amount. Okay. Now let's try. The reason why I logged into Twitch. The reason why I logged into Twitch is because I want to log into Stream Elements, get the HTML for the Emote Wall. Running previously on the Mac, right? The Emote Wall was really like lag, and I had to change my FPS to be like 24 FPS in order for the Emote Wall to work. But all right, here's the Emote Wall. Copy the URL. I don't have any. Where's my Windows multiple desktops? The virtual desktop settings. On the taskbar, map window's fine. My timeline. Alt-Tab. Do I have to new desktop? Desktop 2. This to desktop 2. Where's, let's see, okay, anyway. Okay, so now I have that. Let me add in browser source Emote Wall. Add it by 1080. Use custom frame rate. No custom frame rate now. I don't need to control the audio. Read-only access to OBS is fine. Fresh cache. Okay. Let's try some emotes. Oh yeah, and it doesn't lag. All right, now let's try some harder animated emotes. So for that, my other computer, I'm going to go to .tv/Annie Clover Club. And then let's go into chat. And let's spam some animated emotes. Oh yeah, no problem whatsoever. Look at those emotes. And what's the computer doing? So there is a CPU spike, but the compositing done in the GPU, no problem. So even over PCIe X2, I didn't want to do that. Let me I gotta swap these keys. Yeah, so it does spike up the CPU a little, but keeping the rendering on GPU, no problem. All right, so this works. This was the big problem last time, was the animated emotes. I had to do a lot of like reducing the emotes, because I streamed at 24 FPS and I reduced the emotes to something like 15 FPS or something, in order to reduce the load. And then oh, let's try. I forgot the LUT. Let's add the LUT. Yes. Cam LUTs. Let's go EV-2 sRGB. Now those colors look better, because it was in log mode before. Oh yeah. Wow. Such a big difference. This is a massive difference. Massive difference. There's usually a few frames of rendering lag at the beginning, right? So if I go here, right, and let's say I start, say I watch myself, right, here. And this is a 4K stream that's coming through here. Like nothing. No rendering lag. Interesting. So it's doing hardware accelerated decoding of this stream here using um the iris graphics. See? And no impact on the GPU. CPU goes up. Let's go over to CPU and see if I can notice. Start playing the stream again. All right, so I'm playing the stream. Stream gets paused when it goes in the background. Yeah, but no crazy CPU spikes, right? Wow, right? This is a desktop like experience in that I can stream and watch Twitch at the same time. Now, the setup when we were at Fuse last time was nowhere near this good. And there's plenty of encode bandwidth for me to use the higher spec Stream FX settings. All right, this is going to work. This is going to work. I'm really stunned at how big of a difference this makes. Now, there is a piece here that maybe OBS is not that optimized on Mac, right? That the Windows code is better. No, because it's all of the work is MVEnc, right? It's all encoding work. And that FFmpeg code is right. It's all that FFmpeg code. The interesting is that we're not even taxing. This makes such a huge difference, and there's heat radiating out of the GPU, but it's not generating so much heat that the fans need to run. Yet this makes just such a huge difference, such a huge difference to the the um the usability, right? And like the right, not hardly using any CPU, and this doesn't lag the computer, and I'm not running at like 85 or 90% CPU. All right, so that made the fans move. Okay, that's good. All right. I'm going to stop admiring this setup now. Start tearing down. Next step is going to be a little bit more fun and makery because this setup as is cannot be moved. I'm going to need to design and build a case for this. And that then gets all the cabling routed and kind of bolted down stationary. I'm going to have to figure that out. It's going to be a little annoying to figure out how to properly route all of this cabling down here. That works. I mean, it's been a pain in the ass 3 days. A lot of sitting around and waiting, right? A lot of try something, start the Windows reinstall, whatever, go do meetings, come back and do one command and come back. But yeah, I really thought it wasn't going to work. I was a bit scared when, at first I was pretty hopeful that when I hit the -12, the code 12 issue, and then after the ACPI thing, the Apple boot to keep the iGPU running didn't work, and I kept getting that code 12 problem. I wasn't sure whether or not I'd be able to get it working. And then finally I went for the DSDT fix. And when the DSDT fix bricked the install, wow, that was really a low point. That was like, well, none of the other things worked. The DSDT didn't work. Is this really worth it? Then I put the DSDT in, and it was supposed to be the magic thing, but no, hot plug still didn't work. And then I had to go back and start adding other stuff back in because it was a reinstall, right? So the other stuff that I'd put in Windows, like the hack flags or whatever. And unfortunately, that was early on, right? Once I got the ACPI thing back in, immediately, that was it. That's all I needed. Yeah, that's it. And thank you, Piro, for letting this to me. All right, done for today. Yeah. Now there's only enclosure building and then software work. I'm almost in disbelief given how annoying it was that this works now. And that's it for today. Thank you for watching.